Is my voice audible? Okay. Just write in the comment box what are your doubts, which chapter I should start with. Which chapter I should start with, guys? I'm just asking you. Tell me your preference. Okay, quadrilaterals. So I'll give you a few questions of quadrilaterals. Try solving it. So the question is, show that the quadrilateral formed by joining midpoints of the consecutive sides of a rectangle is rhombus. Solve it. So in this question, try to find out properties of rhombus. You all two keywords are there. One is a rectangle, second one is rhombus, and the third important point is joining midpoints. So first draw rectangle, and then join the midpoints. And name them A, B, C, D, P, Q, R, S. Now what is rhombus? All four sides should be equal. That's how you have to do it. Just try to find out. I have already made the diagram. Okay. Dhruti has done. Okay, done. Tana has done. Shraddha, have you done? Okay, so just for the sake of uh, confirmation, what you need to do is you need to draw this. A construction needs to be done. So I am drawing BD. BD is diagonal of rectangle ABCD. Now, if I take triangle DCB, so what happens in this triangle, that R and Q are midpoint of DC and BC. One second. So RQ would be parallel to DB and RQ would be equal to half of DB. Similarly, if you take other part of triangle which is DAB, similarly you can write that PS would be parallel to DB and PS would be half of DB. If I draw other side of diagram, so from here you can say that opposite sides are parallel and equal. So you can say that PQRS is a parallelogram. Now, if PQRS is a parallelogram, what I need to prove is, I need to prove this, that all sides are equal. So what I will do is, I know that opposite sides are equal in rectangles. So I can write that AD is equal to BC. So half of AD is equal to half of BC. And similarly, so what you can do is you can take this triangle. So you can take triangle SDR, or I have already proved this and this equal. So I can take this triangle SDR and I can take triangle ASP. So here half of AD is AS and half of, or I'll take AD here and DC here instead of this thing. So just give me a moment. Or you can take other side of the triangle also. So what you can do is that this side, if I take triangle ADR, so I know that AD is equal to SD. I also know that as AB is equal to DC, so half of it would be AP is equal to DR, and I know that angle A is equal to angle D, so it would be SAS congruency. So SAS congruency means side opposite to equal angles. I mean SR would be equal to PS. So SR would be equal to PS. So if SR is equal to PS, I have already proved that RQR is equal to SP. Now I am proving that SR is equal to PS. It means that all sides are equal. So you can say that this parallelogram is a rhombus. Write down the next question. The next question is, the diagonals of a quadrilateral ABCD is ABCD are perpendicular. Show that quadrilateral formed by joining midpoints of its sides is a rectangle. Done. Have you all done it? Okay, two people have done, Dhruti and 2 more minutes. Okay, fine. So most of you have done. So I'm giving you next question from quadrilaterals. I don't know whether I have given this question before or not, but still I want to solve it for revision purpose. Prove that line segment joining midpoints of the diagonals of a trapezium is parallel to each of the parallel sides and is equal to half of difference between parallel sides. Do it quickly. Just make the diagram properly in this case. If you make the diagram properly, if the figure is in front of you, you will be able to solve it. Make the diagonals and then join the midpoints of the diagonals. So this is A, this is B, this is C, this is D, and midpoint, suppose I call it P and then Q, and suppose this point is O. Now you will have to do some construction. Okay, so let me solve this question. I don't know how many of you have solved it. Okay, Dhruti has got first part. Solve the second part also. I'm just waiting for that. Okay, I'll solve the second part. So let me solve the first part only. So first try to understand AB is parallel to DC. So this angle, suppose this angle is 1 and this angle is 2. So angle 1 would be equal to angle 2 because there would be alternate interior angles. Now I'm doing a construction. So I'm drawing a line DR through P. So one thing is clear, as P is the midpoint. So let me write down what I know. I know AP is equal to CP. I also know BQ is equal to DQ. Now look at here. If I take this, what I have to prove? I have to prove that this line is parallel to DC and AB. So I'm writing here to prove is PQ is parallel to AB and DC, and PQ is half of AB minus DC. These are the two things that I need to prove. Now, how do you prove that one line is parallel to second line? That's very important. So try to understand. If I am able to prove what is the purpose of drawing this line, why I am drawing this line through P. The purpose of drawing this line to P is that I want to take this triangle DRB. Is it okay? And in this triangle DRB, if I am able to show that P is midpoint of, you can take this from here also. Instead of DR, you can make a point CT or something like that. So what my objective is, I'll use the theorem of the triangle. Which theorem of the triangle? That if I join midpoints of the adjacent side, the line joining that midpoint would be parallel to the third side. For that, what I need to do, I already know that Q is midpoint of DB, but I don't know whether P is midpoint of DR or not. So in this particular case, I'm writing again P here because it's not looking. So what I need to prove is that I need to prove that this P is dividing DR into two equal halves. You should not get confused that P is midpoint of AC. Hence, you can simply write that P would be midpoint of DR also. You will have to prove it here. Now, how do you prove it here? So to prove it here, I should take two triangles. Which are the two triangles? So let me take, you should obviously know that it can be only proved that if I'm able to prove that DP is equal to PR, P would automatically become midpoint of DR. So how will you prove DP is equal to PR? For that, you have to take triangle APR and you have to take triangle DPA. This triangle and this triangle I am taking. So how will I prove here? I know that, or you can do one more thing, because here it is not possible to prove these two lines. You can do one more thing. You can prove on from the other side. You can take this triangle and this triangle. You can take DPC. So you can take triangle APR and you can take triangle DPC. What was the problem in initial one? That you only this line was equal, no other angle was looking equal. Here the angles are looking equal. So I can write angle 1 is equal to angle 2. These two angles are opposite angles. So I am giving it a name of angle 3 and 4. So I am giving it name angle 3 is equal to 4. So these are alternate interior angles. These are opposite angles. And I know that AP is equal to CP. So what kind of congruency it is? It is ASA congruency. So by CPCT, you can write that angle opposite, sorry, side opposite to angle 1 is PR and side opposite to angle 2 is DP. So PR is equal to DP. If PR is equal to DP, it means that P is midpoint of this. Now by midpoint theorem, you can write that RB is parallel to PQ and RB is a part of AB. So PQ would be parallel to AB. AB is already parallel to DC. So first part can be proved easily. Now second part, how do you do second part? So just write it down, then I will do second part. Have you written it? Okay. I hope you have understood this thing. How to do second part, I'll just explain you. So for second part, what I need to do is that so try to understand P and Q are midpoints of DR and DB. So PQ would be equal to half of RB. Now what is RB? So this has been RB is equal to, RB can be written as 1 by 2. RB can be written as AB minus AR. And I know that AR is, so what I proved that, I just proved that triangle APR is congruent to triangle PDC. I just proved it. So look at here, opposite to angle 3 AR is there, opposite to angle 4 DC is there. So I can replace this AR with DC. So PQ is equal to AB half AB minus DC. This is how you have to do it. Okay, solve the next question. One more question I'll give you from this topic and then we'll move to next topic. Okay. So suppose ABCD is a parallelogram, and no, this is not the diagram. So ABCD, I'm saying that ABCD is a parallelogram. Now there is a point E here, E, and there is a point F here. So E and F are midpoints of AB and CD. Prove that line segments AF, so this is E, this is F. So AF, this is AF, and CE, so this is CE, trisect diagonal BD. So I am making diagonal BD. So suppose these points are P and Q. So you have to prove that BP is equal to PQ is equal to QD. Use the properties of parallelogram. Try to prove that AECF is a parallelogram. As soon as you are done, let me know. Try to prove that AECF is a parallelogram and then apply the theorems of triangle. Should I solve? Or Dhruti is saying she has done it. Should I solve, guys? Okay, fine. Two people have done it. Which topic should I solve next? Just write down in the comment box. I've done quadrilaterals for an hour now, so I like to do a different topic. Okay, let me solve. Okay, 3 people have done it. Let me solve it. Now what I need to do, as I told, I need to prove that AECF is a parallelogram. How do I prove it? I know that ABCD is a parallelogram. So AB is equal to CD. Opposite sides are equal. As E and F are midpoint of AB and CD, so half of AB would also be equal to half of CD. So I know that half of AB is E and half of CD is CF. So AE is equal to CF. Now I also know that AB is parallel to CD because it's a parallelogram. Opposite sides are parallel. So part of AB, which is AE, will be parallel to CF also. So AE is equal to CF and AE is parallel to CF. It gives me a case that AECF is a parallelogram. If it is a parallelogram, I can say that now the other part AF is other sides. AF would be parallel to EC, or part of AF, which is QF, would be parallel to CP. Remember this. Why I am using this? Because there is a theorem in triangle that if a line drawn from midpoint of a side to opposite side and is parallel to third side, then that line would be bisecting the third side, bisecting the second side rather. What I am trying to say by this theorem is that this F is midpoint. If I take triangle DCP, so F is midpoint of DC. Now from F I am drawing a line FQ which is parallel to CP. It means that this Q is midpoint of line DP. So Q is midpoint of DP, which says that DQ is equal to QP. Similarly, I can prove it on this side. So how I can prove it on this side? So I can say that this part is parallel to this part. And I know that E is midpoint and a line is drawn. So P would be, so I am saying here for this part that P is midpoint of BQ. Similarly, it means that BP is equal to PQ. So I have proved that BP is equal to PQ and DP is equal to PQ. So all three are equal, which was the objective or which I needed to prove. Okay. So this is how we need to prove it. Let's solve. Okay, I'll give you 1 minute to copy it down. Okay, so we will solve as you guys are telling triangular inequalities. I'll give you a few questions from triangular inequalities. So let me search a few questions from triangular inequalities. Question is, show that the sum of the three altitudes of a triangle is less than the sum of the three sides of triangle. Just prove it. Should I solve it? Should I solve? Okay, 2 people have already done it. Okay, let me solve it. What I have to prove? So let me draw a triangle for you. A, B, C, and let me draw altitudes. So this is AD, this is BE, and this is CF. So this is going here. So all these are altitude. I have to prove that AB plus BC plus CA is greater than AD plus BE plus CF. Now, what I know is that if I take triangle ADB, so there AB would be greater than AD. And on the other side, in triangle ADC also, AC would be greater than AD. So AB plus AC would be greater than 2AD. I am just adding these two equations. Now I am taking triangle BEC and triangle BEA. So in triangle BEC, why they are? Because they are hypotenuse. Both of them are hypotenuse, so they would be greater than perpendicular. So here BC would be greater than BE and AB would be greater than BE. So AB plus BC greater than 2BE. And the third one is, let me take triangle BFC and triangle AFC. So there BC would be greater than CF and AC would be greater than CF. So BC plus AC would be greater than 2CF. Now suppose this is equation 3, this is equation, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9. Add equation 3, 6 and 9. So 2 times AB plus BC plus CA is greater than 2 times AD plus BE plus CF. This 2 cancelled, you get your result. Okay, let me solve next question. Again, I am giving you similar kind of question. Prove that perimeter of a triangle is greater than sum of its 3 medians. Just prove it. You're done. This is extension of the idea that, or concept that, sum of the two sides is greater than 2 times the median. Okay, one person has done it. Two more minutes to solve this. Okay, so idea over here is Suppose this is ABC and these are the medians. So this is D, this is E, this is F. So idea over here is AB plus AC. They are the two sides which are converging on A, or which are coming out from A. That the sum of these two sides would be greater than the median which is being drawn from this vertex, which is 2AD. Similarly, BC plus AB would be greater than 2BE, and similarly CA plus BC would be greater than 2CF. If you add it, you get this answer. Next question. Next question is, so this is some kind of quadrilateral PQRS, and there is a point O here on where the diagonal coincide. You have to prove that PQ plus QR plus RS plus SP is greater than PR plus SQ. This is first theorem that you have to prove. And the second theorem that you have to prove is the same thing. PQ is less than 2 times PR plus SQ. Just try to prove it. Solved. Okay, take your time and solve it. Great. How many of you have solved it? None of you have solved it till now. Okay, 2-3 more minutes. Okay, I'll solve. Nobody is solving, then I'll solve. So in triangle PQR, let's take triangle PQR. So in triangle PQR, PQ plus QR would be greater than PR. Sum of the two sides is greater than the third side. So now let's take triangle RSP, the other side. Triangle RSP. So in triangle RSP, which are the sides? PS plus SR is greater than PR. Now let's triangle SRQ. So SR plus RQ is greater than QR. Now let's take triangle PSQ. So here PQ plus PS is greater than SQ. Now add all of them, you will find that 2 times PQ plus QR plus RS plus SP is greater than 2 times PR plus QS. So this 2 and 2 gone, you will find out your answer. Now next thing that I need to prove is P. So you look at here. Now let's take triangles. These triangles, smaller triangles. So let's take triangle OPQ. So in triangle OPQ, OP plus OQ is greater than PQ. In triangle ORQ, OQ plus OR is greater than QR. Now let's take triangle ORS. There OR plus OS is greater than SR. And now let's take triangle OPS, in which OP plus OS is greater than SP. Add all of these, you will find that OP plus OP is 2OP. OR plus OR is 2OR. OS plus OS is 2OS. And OQ plus OQ is 2OQ. is greater than this PQ plus QR plus RS plus SP. So OP plus OR is PR, so 2 times PR, and OS plus OQ is SQ, so 2 times SQ is greater than this, which I needed to prove. So this is how you have to solve this. Now one last question and then we will wrap up our session. The question is, one second, just give me guys, let me search a good question. So I'm drawing a figure. The figure is something like this. So this is a line L, and this is a point Q, this is a point R, and this is a point A. This is, let's draw a perpendicular from here. So this is AP. And this is angular bisector AS of angle S. So I am saying AP is perpendicular to L, and I am also giving you information that PR is greater than PQ. You have to show that AR would be greater than AQ. How many of you have done it? Okay, Shraddha, I'll explain you second part later. Solve it quickly, 2-3 more minutes. Done. How will you say that, Shraddha? You cannot say like that. You will have to show that which angle is greater angle. So if you want to show, I mean, AR is opposite to greater angle. Which angle is greater? You will have to show that that angle is greater than any other angle, and then you will have to show that AR is greater than AQ. Should I solve this question? Okay, let me solve. So this construction has been done in such a way that PQ is equal to PS. So let me take triangle APQ and triangle APS. So in this scenario, AP is equal to AP, PQ is equal to PS because I have constructed it like that, and angle P on both sides are equal because that is 90 degree. Hence, this and this and this, so side angle side congruency is there. It means that AQ would be equal to AS by CPCT. Now, if I know that AQ is equal to AS, if this is angle 1 and this is angle 2, so angle 1 would be equal to angle 2. Now let's take triangle. Let's take this triangle ARS, and suppose this is angle P. Now, if PR is greater than PQ, so try to understand, in triangle ARS, angle 2 would be greater than angle 3 because exterior angle is greater than, like this 2 would be equal to this angle plus angle 3. I'm not adding this angle, so this 2 would be equal to, suppose this is angle 4, so angle 2 would be equal to angle 4 plus angle 3. So if angle 4 I am not taking, then angle 2 would be greater than angle 3. That's what I am trying to write. The exterior angle is greater than one of the non-adjacent interior angles. So angle 2 is greater than angle 3. So this has been done. Now angle 2 is equal to angle 1. So I can write that angle 1 is greater than angle 3. Opposite to angle 1 is AR. So angle AR. Opposite to angle A3 is angle AQ. So side AQ. So I can write that AR is greater than AQ. So I hope you all understood it. The meaning of this line PR is greater than PQ is that on PR there would be a part which would be equal to PQ. So that is why I have identified a part PS on PR which is equal to PQ. So that is why this point PS has been taken on PR so that this PS becomes equal to PQ. Apart from this, there is no meaning of this. So as soon as you draw PQ is equal to PS and you prove that angle 1 is equal to angle 2, so then you should go to angle ARS and triangle ARS, and you should say that angle 2 is greater than angle 3, and 1 and 2 I have already proved equal. So 1 would be greater than 3. Opposite to 1 AR is there, opposite to 3 AQ is there. So AR is greater than AQ. So I hope you all understood it. Now it's already time, but one question one of you did not understand. So I will explain it once more. So this was PQRS, and there was a point O here. So I told that 2 times PR plus SQ is greater than PQ plus QR plus SR plus PS. So how will you do? You will take this triangle 1, 2, 3, 4. So OR in triangle 1, OP plus OQ is greater than PQ. So this is first equation. In triangle 2, OQ plus OR is greater than QR. This is 2. triangle 3, OR plus OS is greater than SR. This is third equation. And in triangle 4, OS plus OP is greater than PS. Now what happens, you should understand that OP plus OR is equal to PR and OS plus OQ is equal to SQ. So if you add OP plus OR, so see here OP and OR will give you PR, but it is OP and OR is coming 2 times, so it will give you 2 PR on this side. And similarly OS and OQ will give you SQ, but it is coming 2 times, so it will give you 2 SQ, and that would be equal to greater than this summation. So 2 times PR plus SQ is greater than PQ plus QR plus SR plus PS. This is it. So I hope you all understood it. So thank you for joining the session. Now I am wrapping up the session. Thank you so much.